Hi guys, welcome to my channel. Today we're going to do arithmetic of matrices using MATLAB. However, as you know, MATLAB is paid software, so we're going to use an open source alternative called GNU Octave. So let's get started. So let's dive into basic syntax of MATLAB in regards to matrices. So here are your basic syntax. So to do array operations, variable name equals and then brackets around the elements. So they are separate, the elements are separated by spaces. Okay. So for creating 3x3 matrices, so it's like this. So each row is separated by a semicolon. Okay. So here are the basic operations. This is our usual mathematics symbols. Plus, minus. So we have an addition, unary plus, subtraction, unary minus. Then we have element-wise multiplication, element-wise power, right array division, left array division, array transpose. What symbol is this? Is this single quote? Yeah, I guess this is single quotes. Okay. So now, let's try creating 3x3 matrices. Where is it? Okay, there. Let's try creating 3x3 matrices. Okay. Okay, let's name this as A. A is equal to, let's say, 2, 5, 0, negative 1, 3, 1, 2, 4, 6. Okay, as you can see, this is how you create a matrix in MATLAB. Enter. Okay, so as you can see, first row, this one, second row, and this one, then the last row is this one. Okay, let's try creating another one. B is equal to semicolon, negative 9, 2, okay. Same with A. What happened there? First row, second row, third row. There is your third row. Okay. Now let's try operations on these matrices. Okay. First, let's try addition and subtraction. So let's try A plus B. Let's add these two matrices. Okay. So there is our matrix addition. A plus B. Let's try A minus B. Okay. Let's see if it's correct. Let's see. 2 plus 3. Okay, let's go back to the addition one. Okay, 2 plus 3 is 5. 5 plus 9 is 14. 0 plus 6 is 6. So, this is likely correct. Let's not check everything. The video might get long. Okay, subtraction. Okay, let's see. A minus B, right? So, A minus B. So, 2 minus 3 is negative 1. 5 minus 9 is negative 4. 0 minus 6 is negative 6. So, this is also correct. Let's not check everything, because this is likely correct. Okay. We're done with addition and subtraction. Now let's try multiplication and division. Okay. Let's try multiplication. Multiplication is denoted by we use the asterisk symbol for multiplication. So A times B. Okay. That's our matrix multiplication for A times B. And let's try B times A. Okay. They're different because multiplication in matrices, matrix multiplication is not commutative. Okay, then let's try element-wise multiplication. Element-wise multiplication, you just precede the multiplication symbol with a dot. A dot asterisk B. A dot asterisk B. Okay, so this is element-wise multiplication. Let's see. A and B, let's show. Okay, let's see if this is actually correct. 2 times 3 is 6. 5 times 9 is 45. 0 and 6 is 0. 2 and negative 1 is 2. Okay, so this is pretty much correct. I'm yet to discover what is the use of element-wise matrix multiplication in the real world. Okay. Division. So we have two kinds of division here. We have matrix left and matrix right division. Oh, okay. The first one, matrices A and B must have the same number of rows. And the other one, matrix right division, matrices, so A, B divided by A. Matrices A and B must have the same number of columns. In terms of the left division operator, okay. We also have matrix power. Let's go back. Okay. We are in division. Okay. For now, let's follow division of matrices by multiplying with the inverse. So, to get the inverse, we need to use an inbuilt function of MATLAB, which is in then your matrix, something like that. Okay, so let's try dividing A with B. So that will be A times, so the inverse is just raised to the negative 1, right? So raised to the negative 1. Let's put parentheses for clarity. Okay. So that's your inverse. Okay, let's try, let's try B divided by A. Okay. Let's try the division operators. They're quite different. Oh! So therefore, oops. Let's remove this one. Okay. So matrix right division is our matrix division. Okay. For now, let's try matrix power. A, you do it like this, A to the power of 2 or A squared. Okay. Our A is this. This is our A squared. So this is A times A. So matrix A times matrix A. Then another one is the element-wise power. So you just proceed it with the dot. So it's element-wise, so it will just square each element. The first one, the one without the dot, is actual matrix multiplication. Okay. Now let's try getting the determinant of a matrix. Okay. Clear window. Let's display matrix A. Okay. So here is our matrix A. Now, to get the determinant manually. Okay, let's name the determinant as D. Oh, before that, let's assign these elements to variables. So A is 2, B is 5, C is 0, and D is -1, E is -3, F is 1. Next row, G is equal to 2, H is equal to 4, I is equal to 6. There. Okay. Now, for getting the determinant manually, so let's name it as dt. Okay. So, the first part is this one, A, times the determinant of this square matrix, right? So, our A is 2 in that case. But for now, let's put the formula. Okay. So, A times, this is E, right? E times I minus F times H. Then, the next part minus b. This is your b. Then this elements b times the determinant of this square matrix, ignoring the one in the middle. Okay, so b times the determinant of, that's b, right? B times I minus f times g. Then the last part plus c, so this part, and then the determinant of this, so c times this is b times h times, oh no, rather minus e times u. Okay, let's see what we will get. 16. The determinant of this matrix A is 16. Now, let's try getting the determinant of this matrix by using a built-in function. So the built-in function for getting the determinant in MATLAB is def. So def, then the matrix as the parameter. Enter. Answer is 68. So we got the same answer, so I believe I got the formula correctly. Okay. Next, let's try adding and subtracting matrices that does not have the same size. Okay. Let's create new matrices. Let's clear this one. Matrix C is equal to 2, 4, 5, 1, 0, 2. Then D is equal to 3, 5, 1, 2, and 4, 6. Okay, so as you can see, the first one, C, matrix C, is a 2x3 matrix, 2-row, 3-column matrix, and the other one, D, is 3 rows, 2 columns. Okay. Enter. Okay, so we got it correct. 2 rows, 3 columns for C, and then for D, 3 rows, 2 columns. Okay. Now let's try adding and subtracting these matrices. So, okay, it's C plus D. Error. So this is the error that appears when you try to add matrices with different dimensions. So it's error operator plus non-conformant arguments, because it says operator 1 is 2x3, 2 rows, 3 columns, and the operator 2, so the other matrix, is the 3-row by 2-column matrix. So they're not of the same dimensions. Okay, let's try subtraction. Same error. So this program, this language actually conforms to the matrix concepts, that you cannot add or subtract matrices with different dimensions. So this is actually good. Okay. How will you stop the matrices from displaying its content prior to their operation? Actually, I don't know. Let's find out. Okay, so let's try putting a semicolon at the end. So let's try A plus B semicolon. Oh, there! It suppressed the output. Okay, let's try A. Oh, so you put a semicolon. So this is useful for something like this. K is equal to A plus B. So it will just suppress the output. Okay. So actually, I don't have any other implementations here for matrices. I'm just following the concepts of matrices. Okay. So let's try forming column vectors. So row vector. A row vector is a special type of matrix which is a n rows times one column, right? So let's say one. Let's not use 8. Let's use L. So L is the matrix 1, 2, 3. Row vector, rather. Okay? Row vector 1, 2, 3. Okay. We forgot the semicolon. Okay. Then M. For the column vector, your column vector is, it's a no, I stand corrected. Okay. Row vector is one row times n columns, and your see, one row n columns. So in this case, 1 by 3. One row, 3 columns. And then M, okay, let's try M, which is a column vector. A column vector is A. This is a 1 by n. So this is the reverse. This is n by 1. So n rows times 1 column. So that would be 1 semicolon 2 semicolon 3. Okay? So that's our row and column vectors. For matrices, so we did matrices earlier, so that's fine. Okay. Now let's try the differences between A times A times a times a raised to 2, and a dot raised to 2. Okay. Actually, we did this earlier, except for the a times a. So, let's try. Let's clear this window. Let's display the matrix A. Here is our matrix A. 250, negative 131, 246. Let's try A times A. So, this is our A times A. Let's try A raised to 2. A squared. Same answer. So I was right earlier that power operator is matrix multiplication. Okay. Let's try A dot power 2. Okay. What happened? So it squared each element. So this is 2 squared, which is 4. 5 squared is 25. 0 is 0. Negative 1 squared is 1. 3 squared is 9. 1 squared is 1. We have 4. 4 squared is 16. 6 squared is 36. So the first one, matrix multiplication. This is also matrix multiplication. This second one here, a raised to the second power. And then the last one, with the preceding dot, it's element-wise power. So it just squares each element, or whatever number is this. So for cube, so it cubes each number, and so on and so forth. Okay. This is a nice overview of MATLAB. This is a great software, great language, I believe, because you can use usual mathematical notations for solving your math problems. Instead of, in the case of programming, it's quite different. You can't really do this like this. For instance, in programming, you have arrays. You have to use commas to separate the elements, while here in MATLAB, you don't have to. So, pretty convenient, in my opinion. And I think that's all for this video for now. If you like this video, please hit that thumbs up and subscribe for more content like this. You can also comment down below what we will cover next. If you want to know something, just comment it. Okay? I think that's all. Have a good day. Bye now.